cover or figure out how to construct confidence intervals for the population mean again. Population mean again is a mu. But in these types of problems, our population standard deviation is not known. So if you notice on the last section, every time we went through a problem, I underlined the fact that we knew the population standard deviation, which allowed us to use table E. In these, our population standard deviation is not known, which gives us a different distribution. It's called a t-distribution. And that t-distribution, the scores that we use are found from a different table or table F, a t-distribution. Okay, so that's the only real difference here. We're still calculating a confidence interval for a population mean, but we're constructing that based on the fact that we know our sample standard deviation instead of our population standard deviation. So again, in our last formula, we had sigma here instead of S, and then that leads us to a t-score instead of a z-score. So once again, there's the big difference. If our population standard deviation is not known, we substitute our sample standard deviation in S instead of our population standard deviation and use a different table, and again that table is table F. One note on that, table F is based on something called degrees of freedom. Degrees of freedom are sample size minus 1. So whatever our sample size, we go down the left-hand column to our degrees of freedom. You'll see that column on the table. See if we can't pull that table up here. So there's table E, and here is table F, the t-distribution. So notice over here we have degrees of freedom. That would simply be our sample size minus 1. And then we have these 5 confidence intervals, 1, 2, 3, 4, 5. Those would be the only 5 that we calculate for these types of problems. One other side note here, if our sample size gets to be too large, let's say we have a sample size of 50, our degrees of freedom would be 49. We don't have 49 on our table, so we'd actually go all the way down to 45. We don't ever want to be overestimate, so we'll stay conservative and go underneath that number. So again, our degrees of freedom are our sample size minus 1, and then our confidence interval is there at the top. But the big difference here again is the fact that we're working with our sample standard deviation instead of our population standard deviation. So if you compare this to our other formula is this from our previous section is a z-score and a population standard deviation. So noting the two big differences here, t-score versus a z-score because of the sample standard deviation versus the population standard deviation. That one item alone tells us to use a different table. So running down through our first example here, find a 99% confidence interval for a population mean of a sample of 28 has a mean of 212 and a standard deviation of 21. So noticing here our standard deviation is of the sample of 28, so it's a sample standard deviation or S. Our mean is 212 minus, if we go to our table here, I went there too quick, I think. We have a sample size of 28. Oops, that's not good. Sample size of 28, which means I have 27 degrees of freedom and a 99% interval. So I'm going to go to my table now, down to 27 degrees of freedom and across to 99%, 2.771 is the score we're going to use. Our z-score, so 2.771. Our standard deviation, or S, is 21, and our sample size is 28. Other than that, our calculation is very, very similar. We just have to recognize the fact that we're using a different table based on the information that's presented to us. And if we make this calculation, we get 201.0 to 223.00. So again, it all revolves around that sample standard deviation tells us to use table F instead of table E. With table E, we do the population standard deviation. A couple more of those here fairly quickly. Find the 90% confidence interval for a population mean. If a sample is 1462, standard deviation of 42 for a sample of 20. So our sample standard deviation is 42, again S. So as soon as we identify S, we're using table F or a t-score instead of a z-score. Our sample mean is 1462. We'll go to our table again of a sample size of 20, which means I have 19 degrees of freedom. I want a 90% interval, I believe it was, 90%. So I go over from 19 to 90%, and 90% is 1.729. There's our t-score, 1.729. Sample standard deviation is 42, and our sample size is 20. 1462 plus 1.729 times 42 over the square root of 20. And if we make those calculations, I have 1445.76 to 1478.24. So again, simply recognizing the fact that we have our sample standard deviation here tells us to use a different table. One more time, we'll hopefully illustrate that. We should be good to go. Up here, 10 randomly selected automobiles were stopped and tread depth of the right front tire was measured. The mean was 0.32. There's our sample mean. Standard deviation was 0.8. There's our sample standard deviation. Sample standard deviation, table F, or a t-score. Find the 95% interval of the mean, assuming normal distribution. So our mean is 0.32 minus, we have a sample size of 10, which means we have 9 degrees of freedom and a 95% interval. So we'll go to our table, 9 degrees of freedom over to 95%, and we have 2.262. So 2.262 is our t-score. Our standard deviation is 0.08, and our sample size is 10. And we'll make our calculation over here, 0.32 plus 2.262 over 0.08 over the square root of 10. And that gets us 0.263 to 0.377. So again, we're still constructing confidence intervals. Just the difference that we're looking for with our mean is whether we know the population standard deviation or the sample standard deviation. Population standard deviation, table E or a z-score. Sample standard deviation, table F or a t-score. That's the difference between these two types of problems.